Hello, so I'm going to explain pointers today. So pointers, as the name quite rightfully suggests, is something that points to a memory space, a memory address. You store memory addresses in it. So what that means is when you have a pointer, you essentially have access to a part of the memory address which you can then make changes to, which you can edit. So I'm gonna explain how pointers work by comparing it with an analogy of a string puppet. Let's say I've got a struck puppet which has got hands and feet, and I want a new puppet. Well, the way to do it would be to allocate space for it. That is the way of doing it. So now how I'm going to initialize puppet is simply capital P. Anyway, puppet star P. So the trick is to read it backwards, which means that you read it as P points to puppet. This puppet is a struck puppet. So anyway, you got a new puppet now. Now that I've got my puppet, I'm going to do stuff with it. As stated earlier, a puppet has hands and it has feet. So the P pointer would be pointing essentially the entire puppet itself, the struct, and P, now you want to do stuff with it, so you call your meticulously written function move hands, which moves its hands. Now you've got P, you're passing P, and inside move hands you would be doing something like take P's hands. So this is called dereferencing the pointers. So what it does is this follows P to whatever it and sees which part points to its hands. So this part here, I've got this thread over here that points to the hands of this puppet P, and now the function takes this hand, so it has got the actual memory address. Now it's gonna move it up, let's say, for simplicity's sake. Now the actual puppet then moves its hands up. So this is kind of how you get multiple outputs by passing in a pointer to a function. You don't need to return P here because you have here's the key part. You have dereferenced P to its hands, so the changes you make to P will remain. And as for other notable usefulness of pointers, we can make abstract data types like queues, stacks, linked lists, binary search trees, and etc. etc. Hope you enjoyed. Thank you.